In these examples, we're going to solve rate problems. So in the first one it says, if it takes John 9 hours to mow 5 lawns, then how long will it take him to mow 20 lawns? So the first part of the sentence gives us a rate to work with, 9 hours to mow 5 lawns. So we could say 9 hours over 5 lawns. And we could make this a unit rate by dividing 9 by 5, or we can just look at the problem and ask what it's trying to find from here. Then how long will it take him to mow 20 lawns? So let's multiply that by 20 lawns, okay, over 1 really, because it's we're multiplying fractions and this is a whole number, just 20 lawns, so we'll put it over 1 just to make sense a little bit for us. Okay, so let's look at this multiplication problem the way we have it. Remember, when you're multiplying fractions, any factors that are on top and on bottom can be canceled out. So basically, if we see things on the top and on the bottom, let's cancel them. So it looks like the word lawns is on the top and on the bottom. So let's cancel those lawns. And it looks like the units we'll be left with is hours, which the question says, how long will it take him? Well, hours. That's a length of time, so that will be the right unit for us. Is there anything else that can cancel maybe from top and bottom? Well, 20 and 5 looks like I could probably divide a 5 out of both of those. So that goes to 4 and that goes to 1. Okay, so my denominator now looks like everything's canceled out and I just have 1s. So 9 hours times 4, well, 9 times 4 is 36. And the hours are the units, so those will come along for the ride. So it'll take 36 hours to mow 20 lawns, given that he can mow 5 lawns in 9 hours. In this example, it says that for $7, Mary can buy 3 pounds of grapes. So how much would it cost for 12 pounds of grapes? Well, if we know that for $7 we get 3 pounds, we can make a little rate out of that. So for $7, she can get 3 pounds, right? Okay. So what is it that we're looking for? Well, we're looking for cost. So we're hoping at the end of the day we have dollars. And it looks like we have our dollars on top, which is nice. So and for 12 pounds, let's say 12 pounds. And again, since we're multiplying by a whole number here, we'll put it over 1. And remember, anything on top can cancel with anything on bottom, as far as if you see it or if it's perhaps a factor. So automatically I see these pounds. LBS, by the way, is an abbreviation for pounds. So we can cancel the pounds. We're left with dollars, which is nice. That's where we're headed. Then it looks like 3 and 4, we can kind of cancel a 3 out of each one. So we'll divide a 3 out, and that'll go to 1 and 4. So it looks like we have $7 times 4. So 7 times 4 is 28, and that dollar sign is just going to come along for the ride. So $28 we're going to say, we can say for 12 pounds of grapes. And that should be about the price that we expect to pay, given that we can get 3 pounds for $7. In this example, it says that Brandon can drive 300 miles in 5 hours. So that's a nice rate for us, 300 miles in 5 hours. And it says, if that's the case, then how long will it take to drive 2,100 miles? So we have a nice rate. We have 300 miles for every 5 hours, right? And we want to know how long it'll take to go 2,100 miles. So we could multiply this by the 2,100 miles. But, our miles won't cancel because miles are on the top and on the top. So I know that if Brandon can go 300 miles in 5 hours, then it also means that in 5 hours he can go 300 miles. So since I know these two things are equal to each other, it means that I can take the reciprocal and it still is the same thing. And the reason I did this is because I need my miles on bottom so it can cancel with these miles that are on top. But as long as these miles are on top, that can't happen. So I drop them down to the bottom. So I take the reciprocal of this rate. So instead of 300 miles per 5 hours, I say in 5 hours he can drive 300 miles. And then I can multiply that by my 2,100 miles. and I notice nice things. My miles cancel. I'm left with just hours, which is what we're looking for because it says how long will it take. And also, this 2100 and the 300, I can divide a 300 out of both of those. That becomes 1, and this becomes 7. Okay, so if I just have 5 hours and then my 7, I can take 5 times 7 is 35, and my hours here comes along for the ride. So 35 hours to drive 2,100 miles. And that's a long time to be driving. 35 hours for 2,100 miles, as long as Brandon can drive 300 miles in 5 hours. In our final example, if Mike can buy 2 pounds of peanuts for $5, then how much will he pay for 11 pounds of peanuts? So we have a good rate here, 2 pounds for $5. So we'll say 2 pounds for $5, right? And we want to know how much he'll pay for 11 pounds. So we're going to multiply that by 11 pounds. Oh, but we notice again, like the last example, our pounds are both on top. So things aren't going to cancel the way we want them to. So since we want pounds, we need to know how much per pound. So I need to flip this rate again and take the reciprocal. So instead of 2 pounds for $5, I can buy 2 pounds. And now since I know how much peanuts cost per pound, so dollars per pound, I can multiply that by the 11 pounds that I want. So again, you'll see my pounds cancel. Actually, in this case, my 11 and my 2 don't cancel, and the 5 and the 2 can't cancel. So let's just multiply through and see what happens. So I have $55 over 2, which means I need to go ahead and divide that 55 in half, which half of 50 is 25, and half of 5 is 2.5. So it looks like I'll have 27.5. But since it's money, I'll put a dollar sign out front, and I need 2 decimal points, so it'll be $27.50, and we'll say for 11 pounds, I'll scoot it over, of peanuts. So that's how we work some word problems using our unit rates.